The other option is to redefine restraints. Now, we would use probably the inertia relief for running one of these models that are just in hydrostatic equilibrium. But if for some reason you have trouble getting it to run properly, or if there are any type of external loads so that you're not using inertia relief, then we can manually define sort of the traditional restraints. And in doing that, you can define the restraints on the model, but if a specific load case you need a different set of restraints, you can override the default restraints that are built into the model and just add new ones that are specific to this one load case. And that's how you would do them, is with this redefined restraints. As you go to enter some of them, and it's probably easier to see this on the main dialog, so we'll switch over to that in a second, but you can see you've got predefined versions of whether or not any of the points that you add are going to have X symmetry, Y symmetry, X, Y, or Z asymmetry. But once a node is added, we can just add one here quickly. You can toggle on each one of these restraints to cycle through either a free condition, an enforced condition, or enforced displacements. And the displacements can be defined in the cells to the right there. The 1 is a fixed in X, and 2 is the enforced displacement, and 0 is free. And that's a little more clear on the main dialog for defining the restraints. So we'll switch over to the main restraints dialog here when you're adding them to the model. And on the first tab, you have a summary saying how many nodes are currently restrained. And if we turn on the restraints in the graphics, you'll see how they're represented for translation and rotation. And we'll show those in a second. Turn off the water plane here. And under the general tab, this is where the restraints are applied. Now you can either add them from a nodal group, and we've got actually one nodal group, but you can also use the plate cargo groups, or you can specifically pick points off the model graphically. And you can manually set these things. And as you cycle through the checks, first check enforces a fixed condition. The second check changes it to a grade box, and you see it's a DZ, which is the enforced displacement, and then back to a free condition. And there are several that are predefined. So if you want fixed, they're all checked automatically. Pinned just does translation. You can specify no rotation, and then various combinations just for quickly selecting. But we'll do, let's apply a pinned condition here, and we'll grab that node, and then we'll grab another one back aft near the water line. Actually, that's above the water line, but we can say for this aft condition, we don't want to restrain it in X, and we'll leave it restrained in Y and Z. And we'll pick a third point for restraint near center line. Try and grab that point. And this one will only be restrained vertically. Now, it would have been easier if I had unchecked those boxes before adding it and just added it with only the Y box checked. I wouldn't have had to modify it, but once they're entered, it's very easy to modify them in here. Now, there's another way to add or modify the restraints through the dynamic query. And this actually has one additional feature, which is kind of nice, and it may be a little easier. So we'll go into the view dialog, and we'll turn on restraints. Now you can see we switched to a wireframe display, and only our restraints are displayed. Unfortunately, let me say OK to this so they get applied. They're displayed very small. Now there is, in the view options, there is a scale factor for the restraints, but normally you should be able to scale those up to make them a little more visible in your model. And to make it a little easier to find the appropriate nodes that I want, I'll go ahead and turn on the water plane here, because I want to pick nodes them near the water line. My restraints. Now these I picked a little too high. So we can turn on dynamic query in this view, and similar to when we were assigning properties, the plate properties, beam properties, and so forth, if we were viewing by plate ID or by viewing by beam property, when we were doing dynamic query, we could hover on one of the elements and right click and change what property was assigned to it. Well, it's similar in the view restraints mode. If we come in here, and we'll need to be, I think, on a nodal selection. So let me turn on the nodes. And we're still in dynamic query. So if I right click, you can see we have a restraint here. It's only restrained in Y and Z. I can toggle those on and off, or I can remove the entire restraint, and now it's gone. And if we check our restraints dialog, you can see we're now down to 2 restrained nodes, and you can see it's no longer in the list here. Similarly, I'll use the dynamic query and I'll remove this one. The dialog doesn't update immediately. We'll probably have to reopen the dialog to get it to reload. Yeah. But you can see it disappeared from the graphics. So we'll pan around a little bit to see where the other restraint is that I want. So over in the corner, that node right there is the one I want to restrain. So I will add a pinned restraint there. So it does the X, Y, and Z. And you can modify these if you want. The other option that's presented here is the spring connection. And the nice thing about doing it with through the graphical interface with dynamic query is you have this option to use basically a soft spring. And this is similar to when you apply inertia relief to the balance model. It's similar to how it connects the restraint to the model. Creates a node at the center of gravity, and then creates a soft spring to connect that virtual node to some nearby structure in the model. And the soft spring can prevent some stress concentrations from having a hard fixed point directly on the model. And if we add some of those, so we'll make this next one using the soft spring, and we just want to put this one in Y. And I think I might need to refresh the display to actually see it. So turn off dynamic query so that I can get to the refresh dialog, and you can see it created a vertical line there. I'm going to switch back to element view so we can see it. So it created this spring and the restrained node there. So if we switch back to view the restraints, now you can see the XYZ restraint on the end of that spring. So it was restrained in all nodes, but the spring is in the Y direction. I can change that if I only want this to be restrained in certain directions, because it's just creating an additional restraint node. And we can similarly remove it, but removing the restraint node does not remove the spring. So if we come back into the element view, you can see the spring is still there, even though the restraint is gone. So we have to manually delete that spring. When it creates that spring, and if we come under the properties and we go over to the spring tab, the inertia relief spring is entered in there by default, and it has 1 times 10 to the 6th spring constant for X, Y, and Z. Now, when we created that spring, it was in the Y direction, so it only has a spring constant in the Y direction. It's 0 in X and Y. We could create one with an X, Y, and Z spring constant. If we come back into the restraints view, dynamic query, and spring menu, and there is an XYZ option. And if we create one of those, it creates a fairly short spring. We need to refresh the view. You can see it's this small vertical spring that it created here. And let me close this dialog and reopen the properties. And you can see now there's a B spring XYZ with, I guess it uses 1 times 10 to the 8th as the default spring constant, but it's for all 3 directions. You should be able to modify this value in here. You can come into the springs and edit these. I have to edit it up here. So if we add 0 on that and modify. Oh, I just did that to the inertial relief spring. I highlighted it here. I should have double clicked to get it up into the main dialog up there. If I had double clicked so that the B spring XYZ is my current, we could modify that there. Now, I don't know if it's going to create a different B spring XYZ if you created a second one. We can try that right now. I have normally used just the inertia relief, so I haven't typically been running with the traditional constraints, but let's add another spring XYZ, and we'll see if it creates a unique one now that that one has been changed. No, I think it uses the same one. But if we were to rename it, and then come in here and create another restraint with XYZ, that will allow us to have two different, or to use different springs for different restraints, even though they're all in the XYZ. Just change the name, and when it doesn't see it, it'll create a new one. You could probably also just manually reassign the spring. I don't think there's anything special about those springs. It's just a standard element in the model. You can probably just come in here and manually modify them or reassign them to a different spring that you've defined just under the element view.